Hey guys, so Serum 49 is solving systems of equations in context. Up until this point, we haven't really given our systems any meaning, but that's what we're going to do starting today. By the end of this video, you should be able to apply systems of equations to real-world settings. What you're going to be getting is you'll be getting a problem itself. You'll have to be able to identify certain information and create your system and solve from there. So when we're solving these systems, there are going to be 5 steps that we are following. We're first going to determine the question. We're secondly going to define our variables. That's something we haven't done so far, but it's going to be very important to kind of keep yourself organized. Thirdly, we're going to be translating the problem into 2 equations, or the system. Fourth, we'll solve the system by using the best method. We have 3 methods that we know of. The first method is graphing. The second method is substitution, and the third method is elimination. So we are going to choose which of those 3 methods work best, and then fifth, we're going to go back to the original problem and analyze our solution based on the context. So for this first example, I'd like for you to have all of this written in your notes, so go ahead and pause the video and write this down now. Alright, so we're going to go ahead and follow the 5 steps. The first step is to determine the question. Before we do that, we're going to actually do a read-through of the problem. So it says of the 17 species of the penguins in the world, the largest species is the emperor penguin. One of the smallest is the Galapagos penguin. The total height of the 2 penguins is 169 centimeters. The emperor penguin is 22 centimeters more than twice the height of the Galapagos penguin. Find the height of each penguin. Well, what I'm looking for, or the question that I'm trying to ask, is how tall are each of the penguins? So find the height of each penguin. That's going to bring us to the second step, which is to find the variables. If our unknowns, if what we're looking for is the height of each penguin, we're going to have 2 different variables. The first one I'm going to label as G, which is the height of the Galapagos penguin. You'll notice that I am being very specific with my variables, and I will explain why in a second. So my first unknown was that height of the Galapagos penguin, and then secondly we have the height of the emperor penguin. So I'm going to make that E, my variable E, and that's going to be the height of the emperor penguin. So the reason why I'm being so specific rather than just saying Galapagos penguin and emperor penguin is because I don't know what that says. If we just said G was Galapagos penguin, it could be the number of Galapagos penguins. It could be numerous things. So we want to be super specific when we do make our variables. So the number 3 says to translate the problem into 2 equations, or the system. So we first need to figure out what those 2 equations are going to be. So if I go back and look at my problem again, it says of the 17 species of penguins in the world, the largest is the emperor penguin. Well, 17 is a number in there, but I don't really care about all 17 species. I'm only worried about that largest species, which is the emperor penguin, and the smallest, which is the Galapagos. So we're not going to worry about that number. If we keep going, it says the total height of the 2 penguins is 169 centimeters. Well, we're looking for the height of each penguin, so I'm going to guess that that total height of the 2 penguins is going to be really important. And then the next sentence says, the emperor penguin is 22 centimeters more than twice the height of Galapagos penguin. Again, I think that that sentence is going to be pretty helpful when creating our system, so I'm going to go ahead and underline that in blue. And then we already know our question is find the height of each penguin. So now what we need to do is we need to go back to those 2 sentences we underlined, and we need to see if we can figure out our equations. So the first one in green says the total height of the 2 penguins is 169 centimeters. Well, I have defined 2 variables, G, the height of the Galapagos penguin, and E, the height of the emperor penguin. If I want the total height of the 2 penguins, that's going to be the sum of G and E. So G plus E will be 169 centimeters. Once again, the total height of the 2 penguins. So if I add the height of both penguins together, I'll have 169 centimeters. That's what this says here. My second sentence says, the emperor penguin is 22 centimeters more than twice the height of the Galapagos penguin. Well, this is going back to one of our previous standards where we went from words into numbers. So we're just going to use those same words. So it says the emperor penguin, that's our variable E, is, remember is equals 22 centimeters more than, so we know that we'll have 22 plus, twice the height of the Galapagos penguin. Well, I know twice the height is going to be 2 times the height, and the Galapagos penguin has the variable g. So what we have now are our two equations or our system, and we can choose which method we need to use to solve this system. So if we look at what we have here, we have one of our variables e already solved for. We know that e equals 22 plus 2g. So I'm going to go ahead and substitute that in for e in my first equation, and what we'll get is g plus, where e was, 22 plus 2g equals 169. I'm going to go ahead and drop those parentheses. I'll have g plus 22 plus 2g equals 169. And now this is just combining our like terms and solving an equation after that. So g plus 2g will give me 3g. Bring down the plus 22 equals 169. If I subtract 22 from both sides, I have 3g equals 147. I next need to divide both sides by 3, and I get g equals 49. So that 49 described the height of our Galapagos penguin, and if we go back to our problem, these are all in centimeters. So I'm going to know the height of my Galapagos penguin is 49 centimeters. I still need to solve for the height of the emperor penguin because our question was to find the height of each penguin. So I'm going to go ahead and take this 49 and plug it back into that green equation for g so I can solve for e. So we'll have 49 plus e equals 169. I'm going to subtract 49 from both sides so I can get that e by itself. And what I'll get is e equals 120. Once again, if we go back to the context of the problem, we have that our Galapagos penguin, the height of it is 49 centimeters tall, and the height of our emperor penguin is 120 centimeters. This is going to be our final answer. Alright, example 2, go ahead and pause the video and write down this question. It says, for a future Teachers of America fundraiser, Denzel sold pizza for $5 and subs for $3. He sold 11 more subs than pizzas. He earned a total of $233. How many pizzas did he sell and how many subs did he sell? Well, first we're going to determine our question, which is how many pizzas did he sell and how many subs did he sell? So we should be able to answer both of those by the end. 2 is to define our variables. Well, we do not know the number of pizzas he sold, so 1 will be P for number of pizzas sold. I'm just going to write number of pizzas, but we know this is number of pizzas sold. And then we'll have S for number of subs sold. Then we go on to 3, which is translate the problem into 2 equations. So if we go back to our original problem and underline important details, we have that he sold pizza for $5 and subs for $3. We also have that he sold 11 more subs than pizzas, and he earned a total of $233. Okay, so this one's a little bit trickier, but I think you guys can definitely do it. Let's go ahead and use what we underlined to create our 2 equations. So the first piece of information that we have is that he sold pizzas for $5 and subs for $3. We also know that he earned $233 total. So using our variables, if we know that for each pizza he sells it's $5, we can have 5 times P. We want to add on how many subs, or how much his subs were and how many he sold. They were $3 a piece, so we'll have 3 times S, and we know that he earned a total of $233. So what we have is $5 per pizza plus $3 per sub will give me $233 by the end of the day. So that's going to be our first equation there. And then our second one is he sold 11 more subs than pizzas. So what I'll end up getting is I know that my subs are 11 more than the number of pizzas that we sold. So we have S equals 11 plus P. So what we can do now is go ahead and solve this system. I know that S equals 11 plus P, so I'm going to take that and plug it into S in my first equation. What we'll have is 5P plus 3 times 11 plus P equals 233. I'm going to multiply my 3 through, distribute it. So I'll have 5P plus 33 plus 3P equals 233. Combine my like terms. 8P plus 33 equals 233. If I subtract 33 from both sides, I'll have 8P equals 200. Then I'm going to divide both sides by 8, and I will have P equals 25. Okay, I need to go back and solve for S, so I'm going to plug P into that blue equation. I'll have S equals 11 plus 25, so S equals 36. If we go back, number 5, analyze the solution in context of the problem. He sold 25 pizzas, because P is number of pizzas sold, and he sold 36 subs. S is number of subs sold. This is our final answer. Alright, so here's the U-Try. It's going to be a little bit different than something we've done so far, but I think it's a good enough challenge that you guys will be able to persevere through, and be sure you bring this into class tomorrow. Good luck!